What's up, Webster? This is Chemistry Goal 7. In this goal, we're describing how heat is transferred. Heat can be transferred in three different ways. Hopefully, these words are familiar to you. Those ways are convection, conduction, and radiation. You need to identify when those transfers are happening and be able to what those different transfer methods are. The other thing you need to know is the difference between heat and temperature. Whoa, crazy. Okay, so here we go. What is heat? Heat is the total amount of thermal energy in a system. So if we're adding the thermal energy of this molecule plus the thermal energy of this molecule plus the thermal energy of this molecule plus that, you get the idea. Okay, so heat is the total amount of thermal energy in a system. And all matter has heat because we know that all molecules are moving unless they're at absolute zero, which is still currently a theory rather than an actual reality. Okay, so all matter has heat because all molecules are moving. It doesn't matter if it's a solid because they're vibrating, a liquid because they're moving freely, or a gas because they're moving very freely. All matter has heat. Okay. On the other hand, temperature. Okay, temperature is the average thermal energy in a system. Okay, so if we put a thermometer into our system here, okay, it is going to tell us the average thermal energy in that system. Okay, so average means you add up the thermal energy of every molecule and you divide by the number of molecules you have. Okay, but it's an average. It's not the total, it's an average. Okay, so you can have more heat in a system that has a lower temperature. Okay, and that can be confusing, so let's look at that. Okay, what's the difference between heat and temperature? So heat is the total amount versus temperature as the average amount. Okay, so which of these circumstances has more heat energy? A cold lake on a winter day or a piping hot steaming cup of coffee? Okay, which one is going to have more heat? If you think about heat as the total amount of thermal energy in a system, the lake on the winter day is going to have more heat because there's a whole lot more molecules that are moving in that lake. Okay, and so as a result, if heat is the total amount of movement of all of those molecules, total amount of thermal energy, the lake is going to have more heat. On the other hand, if you put a thermometer in the coffee cup, it's going to read a higher temperature than if you put a thermometer in the lake. Okay, because on average, those molecules have more thermal energy in the coffee than they do in the lake. There's those molecules in the coffee mug are moving around a lot faster, but there's a lot fewer molecules too. Okay, so temperature is the average amount, and on average, if we look at the coffee cup, those molecules are moving faster. Okay, those molecules are moving more, and so they have more thermal energy. But the lake has greater number of molecules, so it's going to have more heat. So, hopefully you've heard of these transfer methods before. Conduction, convection, radiation. These are the way that heat is transferred. And when heat is transferred, it moves from warmer objects to colder objects. We know that by putting a pot of boiling water on the stove, or putting a pot of water on the stove. That heat energy from the stove moves into the colder pot of water on the stove. Okay, so here we go. Conduction. Which of these would match up for conduction? Conduction is the transfer of energy through matter from solid particle to solid particle. Okay, so conduction happens in solids. And that would match up perfectly with our picture here, because the burner is heating the metal rod, which will eventually heat up the person's hand. Not smart. Don't do this. Not a good idea. Okay. Convection. Convection is the transfer of heat by the actual movement of warmed matter. Okay. So that matches this definition, and that is going to match this picture. Okay. Because we have, in convection, we have air that is warmed as it rises, because it's less dense warm air, it begins to cool. And as it cools, it sinks back down to the bottom. Okay? And so this is what powers a lot of our weather systems. And so you may remember these words when you talked about weather in 7th grade. Okay? Convection is what powers a lot of our weather systems, and that rising, less dense warm air, and then the cooling, more dense cold air, okay, is what's happening with convection. It also happens with liquids. Anything that's a fluid, gas or liquid, convection can happen in. Radiation is the heat waves that directly transport thermal energy through space. Okay, so this is like the sun warming the earth. Okay. Also, like if you stand in front of a heater and you feel the heat on your face, that is the heat energy traveling through a space to you. So those are the 3 ways heat can be transferred. You're going to need to identify these ways. Okay. So if you look at a picture, you should be able to identify which one is convection, conduction, or radiation. So let's look at a picture. Okay. If we have this kettle on a burner, where is convection, conduction, and radiation happening? Radiation would be happening here. The burner is heating the air around it, and so the air around it gets warmer, which is going to cause this ice cube to melt. Conduction would be like the hot burner directly to the kettle. Okay, solid to solid, that is conduction. Convection is happening inside the kettle, because we have water inside the kettle. And so as the warm air warms up, it rises to the top of the liquid, and then it cools, and as it cools, it sinks back down to the bottom. Okay, so that would be convection. So in this example, all 3 methods of heat transfer are happening. Okay, let's watch some Bill Nye to finish it out, and then we're done.
Here's a question. Which has more heat energy? This hot burning match or this beautiful ice sculpture of science? Well, the match is hot, right? Sculpture's cold. Well, they're both made of molecules, right? But which has more molecules? The ice sculpture. A lot more molecules. So although they're much colder than the match, they actually have more heat energy. More molecules, more heat energy. Think of it this way. Suppose you tried to take a burning match and use it to melt a whole ice sculpture.